Hey guys, so today we're going to be talking about solving, that doesn't look right, that looks better, solving one-step and multi-step equations. So I'm just going to call it multi-step equations. So we're going to start, old-fashioned way, 2.2 and 2.3, solving multi-step equations. Okay, so we're going to start by talking about a couple properties. We talked about properties in chapter 1, but these are different properties. So these are going to be the properties of addition of equality, property of subtraction property of equality, multiplication property of equality, division property of equality. So I'm going to write them this way. Oh my, it'd be right if I wrote it the right one. So I had addition property of equality, subtraction property of equality. So these are the equalities. Equality, try that again. Okay, and these two, we would say, undo each other. So if I have addition going on in a problem, I would undo the addition by subtracting numbers from both sides. So the goal, again, what we're trying to do is to get our variable alone and solve for our unknown, not guess what's supposed to be there. Now when it comes to the other guys, we've got the multiplication property of equality, and we're going to be talking about it with the division property of equality. And again, they undo each other. So again, what we're learning now is making sure we understand the process of solving an equation. It's not, what do I think goes in the place of the variable to make this a true sentence? No, it's do the math using these properties to undo what's going on. So the goal in any equation solve, not guess, solve for the variable. Okay, that's our goal. Okay, so let's talk about a process and then we'll do some practice. And the process is the same, except for if you have more than one thing going on in a problem, then it's going to just take you a little bit longer. So we're going to have to think about this. So our goal is to solve for the variable. In other words, let's say that we want to isolate the variable on the left and equals the answer. Okay, so that's what we're trying to get. Isolate the variable on the left, and on the other side of the equal sign will be the answer. Okay, so we have subtraction undoes addition, addition undoes subtraction, division undoes multiplication, multiplication undoes division. Okay. Oh, let's add a couple more words to make sure you understand these, because we will be using them, and we've talked about these words before. So we've got a constant, and that is a number that stands alone. Without a variable. Okay, and then we've got the coefficient, and that's going to be the number being multiplied by a variable. Okay? Alrighty, so we're just going to go through some examples, and we'll see how that works out, and we'll just kind of talk about the process as we go along. So the directions are just basically going to say solve. Okay. So first one, we have m plus 12 equals 10. So what we're going to do is we have addition in this problem, so that means we're going to use subtraction property of equality to solve. So we're undoing the addition by subtracting. So whatever value is on the same side as the variable, that's what we're going to get rid of. Now here's what's kind of interesting. When we're solving an equation, so this is just going to be m. These guys are opposites. Opposites add to give me 0. That's the inverse property of addition. And then equals -2. And you can check it to make sure that it makes sense. And it's as simple as just saying -2 plus 12, does that actually equal 10? And we get 10 equals 10. So the answer is, yep, it is m equals -2. Okay? So, I totally lost my train of thought. It'll come back. Oh, so we're used to order of operations where we're looking for grouping symbols, and then exponents, and then multiplication or division, and adding or subtracting comes last. And it's weird because actually we end up doing adding or subtracting first so that we can get the constants together. And then we would do multiplication or division if we wanted to get rid of any kind of coefficient. Okay? So we're just going to do some one-steppers here. So we have -2 equals g minus 9. So this is the point where, remember, we're not being asked to solve for -2, we're being asked to solve for the variable g. So what I can do, because my g's on the wrong side, is I can pick up the two sides of my equation and switch them. So if you remember, this is, to do this, that's the symmetric property of equality. It looks like the commutative property, but it's not, because that's over addition or over multiplication. This is over an equal sign. So that's your symmetric property of equality. Okay, so I have subtraction. So what I want to do is undo it using addition. So again, it's whatever is on the same side of the variable that's dictating the math. So I'm going to add 9 to both sides. And I get g, and when I add opposites, I get 0. And then signs are different, so I'm going to subtract bigger numbers positive, and 9 take away 2 is 7. So then I'm just going to check it. And I always go back to the original. So is -2 the same as 7 take away 9? And let's see, signs are different. Bigger numbers negative. 9 take away 7 is 2. That checks. So it says, yep, that answer is good. Okay? Let's see. 3. We've got negative 7y equals negative 91. Okay, so now I've got a multiplication problem. Remember, when you have a number butted up to a variable, it means to multiply. When you have a variable butted up to a variable, it means to multiply. They don't have to show you the multiplication symbol. So, to undo multiplication, I would use division. So I'm going to divide both sides by negative 7. Okay, and negative 7 divided by itself is 1. Okay, when I multiply inverses, and it actually kind of works with division, when I divide a number by itself, that's the same thing as multiplying by a reciprocal, kind of weird, I get 1. If I do 1 times y, I get y. That's identity property of equality. So 2 negatives make a positive. 7 goes into 9 once with 2 left over. 7 goes into 21 3 times. So I get y equals 13, but I'm going to check that. Is negative 7 times 13 actually equal to negative 91? Well, signs are different, so it's negative. 7 times 3 is 21. 7 times 1 is 7 plus 2 is 9. And sure enough, I get what I want, so that says, yep, your answer has to be y equals 13. All right, let's do one more over here. And let's do a over g. Nope, sorry, can't be a over g, a over 9, which is really a divided by 9 equals negative 4. All right, this is where you guys are going to have to really pay attention and really follow what I ask, because this is one of the things that really drives me nuts. A mathematical pet peeve. Okay, so right now I'm dividing a by 9. So in order to undo the division, I have to do multiplication. But here's the deal. Where I'm going to multiply is up high. Why? Because I want it to be 9 divided by 9. Let me show you what I see from a lot of kids. This is what I see them write. But really, what I would be writing then is 9 over 81 equals negative 36, and that's not what you want, right? So I'm going to erase all of that. So that's my pet peeve. And I see it, and it drives me crazy. Don't do it. Because you don't need me any more crazy than I am. So we're going to multiply both sides by 9. Now, where you choose to multiply on the right side is up to you. If it makes it easier for you to remember, multiply on the top. So you're multiplying top, that's fine. Do it. If you need to multiply underneath, fine. Whatever. So then we go ahead and we multiply, and I notice that when I do my math, we get 9 divided by 9 is 1. 1 times a is a. Signs are different, so answer is negative. 4 times 9 is 36. So I'm going to check that. And I get negative 36 divided by 9. Is that actually equal to negative 4? Signs are different. Answer is negative. 9 goes into 36 4 times, and that checks out. So that says, yep, a equals negative 36. So here's the other pet peeve that I get. Do I have to check my answer? And then my response is, depends. Do you want you to find out if you made a mistake, or do you want me to find out if you made a mistake? If I find out you've made a mistake, now it's going to cost you points. And we really don't want that to happen, right? Okay, so those were the easy ones. Those were the only one thing we needed to do. So let's get some multi-step problems going on. All right, so we're still on the same set of notes. We still have the same, oops, still have the wrong color. instructions are going to ask us to solve. Our interpretation of that is we're going to do get the variable alone. So let's see. Question 5. Let's do this one. 6x plus 8 equals 50. So now we have two problems, two different operations to do. Before we just had one. So let's jot down a little quick note. We're going to start with, as we mentioned, undo adding or subtracting, and that's going to remove the constant. And then we would undo the multiplying or the dividing, and that's going to remove the coefficient. Now, if we did the coefficient first, so we did the multiplication or division first, we can end up creating, let's look over here. Oh my gosh, I've created fractions. Eek! That's why we don't do that. We do the constant first. Oops, I went backwards. So we have adding, so we're going to do subtracting. And so we're going to subtract 8 from both sides. There's going to be 6x is equal to 42. And then the inverse operation to multiplication would be division. So we would divide, again, whatever is on the same side as the variable. That's what's going to dictate the math. So we have 6 divided by 6 is 1. 1 times x is x. And then 42 divided by 6 is 7. So we can check that. Takes a little bit longer now. That's a question mark, hard to tell. Oh well. And then we get 42 plus 8, 50, and yep, we get 50 equals 50. So then we have to say, yep, x has to equal 7. Let's see if we can do one. Cram one in over here. All right, let's do this one. Yeah. 7 minus 3y is equal to 34. So again, we look for the constant, and we've got a positive 7, so we're going to undo it using subtraction. So we're going to subtract 7 from both sides. Now, one of the most common mistakes kids make has to do with signs. There's a negative in front of that 3y, it stays. Over on the other side, we get 24. So then we undo, let's see, using our division. Oh, I did my colors wrong, didn't I? Dang, nabbit. All right, I'm just going to cheat. Blue. Blue. Now it's red. And we're going to divide both sides by negative 3. So we get y equals negative 8. So we can do a mental check, which, by the way, is possible. However, it is easy to make a mental mistake. So let's see. Negative 3 times negative 8 is positive 24. 7 plus 24 is going to give me 7 plus 24. Oh, wait a second. I made a mistake, didn't I? I said 14 take away 7 was 4. Yeah, I was going to say, this is not looking right. I made boo-boo right there. 7 take away 7 is 7, and 27 divided by 3 is 9. That makes more sense. Yeah. So negative 3 times negative 9 is negative 27, or positive 27. 27 plus 7 is 34. That matches. See, I started doing the math going, wait a second, that doesn't make sense. There's a lot to keep track in my brain. Okay. Now, let's get into some dicier problems. Where it starts getting a little dicier is when we start involving some fractions. Fractions. So let's put number 7 over here. And let's do x over 2, take away 7, equals 9. Okay. So again, job 1, we're going to undo using adding or subtracting to remove the constant. So I'm going to go ahead and add 7 to both sides. Now remember what happens with 7 and negative 7, we get 0. So that's going to leave me x over 2 equals 16. But it's not x over 2, it's x divided by 2. So the inverse of dividing is multiplying. So we're going to go ahead and we're going to multiply by 2 on both sides. Now again, nice and high, because that's going to give us 2 divided by 2 is going to give us 1. 1 times x is x. And then we have 32. So 32 divided by 2 is 16. 16 take away 7 is 9. 9 equals 9. So I agree with that answer. See, if I didn't do my checks, I would have gotten number 6 wrong, and then I would have gotten complaint emails. Miss Roger, you made a mistake. Yep, I did. All right, let's do another one like that, and then I'm going to show you kind of interesting questions. So 2 more, and then you'll be done for today. Negative 10 plus 7 fourths p, ooh, this one is interesting, equals negative 38. Okay, so we want to undo the constant, but the constant is negative, which means we're actually going to add. Okay, so we're going to add. So we're going to add 10 to both sides. That leaves me with 7 fourths p equals negative 28. Now, here's the part where, believe me, trust me on this one. If I want to get rid of a coefficient, that is a fraction. Okay, I want to get rid of a coefficient that is a fraction. I can do it in 1 step. I could do it in 2. I could multiply both sides by the denominator and then divide by the numerator. But if I multiply both sides by the reciprocal of the coefficient, it's going to completely remove 4 divided by 4 is 1, 7 divided by 7 is 1. Bam, in 1 step, gone. Okay? So I'm going to put a little note over here. Multiply by the reciprocal of the coefficient. Oh, I'm going to write him down. That's going to interfere with everything. Coefficient. Now remember, the coefficient is what's attached to the variable. Okay? So what do we got? 1 times p is p. 7 goes into itself once, and into negative 28, negative 4 times. Negative 4 times positive 4 is negative 16. All right, this one's way too much for my brain at this time of night to do, so I'm just going to go ahead and check it this way. So 4 goes into that negative 4. We have negative 10 minus 28 Oh, yep. Negative 38 equals negative 38. So my answer is P equals negative 16. All right, oops. Go back to black. Last one. And this one's the most interesting. The most interesting problem that exists. What if your variable is involved in a fraction? Wow. So let me show you how to do this one. Now, this one, I cannot multiply by the reciprocal of a fraction, right? Because it's a sum up at the top. I'm adding 11 to the x. So here's how we handle this one. We're going to get rid of the denominator. So he's dividing, so I'm going to use multiplication, okay? So I'm going to multiply both sides by 8. Now be careful, look what's happening. 8 divided by 8 is 1. Do not distribute that 8 on the top, my friends. Leave it as 8, okay? Now, over here, I've preserved the numerator. It's not going to change. X plus 11 stays x plus 11. Other side, I have negative 24. The inverse of adding is going to be subtracting. So I'm going to subtract 11 from both sides. And I get x equals negative 35. So I am going to check that one. And I have negative 35 plus 11 divided by 8. Is that actually going to equal negative 3? Let's see. That's going to give me negative 24 over 8 equals negative 3. Negative 3 equals negative 3. Check. And there she blows. All right, good luck with this, guys. A lot of stuff to think about. See you later. Bye-bye now.